Hi, Assalamualaikum. We are from Group 8 and today we're going to present about our group project, which is the DC motor in PID controller system. Hi, my name is Muhammad Irfan bin Kamid. My metric number is 197046.
Hi, my name is Nurul Hanis binti Zawawi. My metric number is 197542.
Hi, my name is Muhammad Alif Haikal bin Biamin, 197273.
Hi, my name is Nadlina binti Muhammad Nazri and my metric number is 198592.
Hi, Assalamualaikum everyone. My name is Azrul Azim bin Ahmad Islam and my metric number is 198954.
Okay, so this is some of the things that we're going to present today. The first one is introduction. The second one is objective. The third one is a literature review. The fourth one is application of DC motor in different systems. And the fifth is methodology. And next is mathematical model. So the seventh is analysis data. Next, discussion, conclusion, and then we're going to state the references. Okay, so for the first one is introduction. Direct current motor, or known as DC motor, is a type of electrical motor which is transform electrical energy into mechanical power. DC motor use direct current to translate electrical power into the mechanical rotation. The stator is known as the stationary component of an engine, as it gives a rotating magnetic field in a DC motor that drives the armature to spin. DC motor will use the stationary series of magnets in the stator and the coil of wire with a current flowing through it to create an electric field. DC motor has two main components as its core, which are stator and armature. There are several types of DC motor, which are known as the main type of DC motor, which is brushless, brush, shunt, and series. Okay, so next is the objective of this project. So the first objective is to acknowledge the application of DC motor in different systems. The second one is to develop the mathematical model of the DC motor in the PID control system. The third one is develop and know the feedback and response of the system that will control the speed of the DC motor. And the last one is to design the controller by using the root locus technique.
For the next one, it is the literature review. So, from the chosen literature review in the research article presented by Pablo J. et al. 2018, titled PID Controller Designed for DC Motor from the Universidad Tecnológica de Pereira, Colombia. The analysis of the DC machine, DC motor, was presented. So, starting from the third model of the system, the parameters of the commercial machine were used. In the system, the PID controller was infused in order to control the speed omega of the motor rotor. In the system, the PID controller was infused in order to control the speed omega of the motor rotor. Also in the study, the system of the equation were obtained from the circuit by using the Kirchhoff law of mesh current for armature and field circuits. And Newton's law were used also on the summation of torques for the rotor of the machine. The calculation and derivations were shown on the study paper. Using the Ziegler-Nichols criterion, a PID controller is required to be tuned, which consists of finding a gain Kc, with which the system's response to a unit phase input for the closed loop system is oscillatory and periodic. The controller's proportional constant and the oscillations period, PC, are calculated from this gain, from which the time constant used to calculate the integral gains Ki and the derivative Kd are defined.
Next, I'm going to present to you about application of DC motor. DC motor have a few many application. Some of it is such as DC motor for toys. DC motor for toys mostly used for can be used in remote control cars and model trains. The system that is used for DC motor for toys is closed loop system, which is for remote control car. Next is DC motor for fan. The DC motor for fan is used in DC motor ceiling fans. It is more economical than their AC type, and also the system that is used for this motor, the DC motor ceiling fans, is mainly open loop. Next is DC motor for pump, which is used in hydraulic pumps. Hydraulic pumps mostly used in construction, mines, manufacturing, and stainless steel. The pump that is use system open and also closed loop.
And as for the methodology, I will present. First, we choose the design of DC motor system from the literature review and do the block diagram roughly. And then we derive the transfer function of the system and design the mathematical model by seeing the literature review. And then by using MATLAB Simulink, we are able to create the mathematical model. And we also have to insert the transfer function that we design in MATLAB, and we are able to generate the data from the system feedback and the response.
Okay, so next for mathematical model, I'll present about mathematical model. So for the first one, the Simulink model of DC motor system. This one is made by using the MATLAB Simulink program. So in here we can see the PID controller on the left side and the DC motor system. Okay, so next slide. Okay, so next one is the open loop transfer function that is used for this DC motor. So you can see in the screen right here. Then at the bottom of it is the model configuration of the PID controller, which is also made in MATLAB Simulink program. Okay, next for analysis data. First one is the uncompensated system, which means without the PID controller. So here you can see the step response performance. The settling time is 1.59 seconds. The percent overshoot is close to 0%. And also the system is stable. So basically from the uncompensated system, it is already met the requirement given. But still we can still further stabilize the system by tuning the system. So we need to find the PID parameters. So in the MATLAB program, we find the controller parameters output by using the PID tuner tools. So the PID tuner is a graphical user interface GUI tools that are provided by MATLAB program. And then the system is compensated by adding these PID parameters KP, KI, and KD. So for next one. Okay, so this one is compensated system, which is already included with the PID controller. So we get a different step response. So for this one, the step response performance have a settling time of 0.202 seconds, and percent overshoot is close to 2.21%. And also the system is stable. Okay, discussion on the analysis. Next. Okay, what you can see from the both graph of uncompensated versus versus the compensated system. So we know the both system is stable, and then the steady state error for both system is 0. The settling time in compensated system is much shorter than in the uncompensated system. So this shows that the compensated system will reach stability faster than the uncompensated system. So okay, that's all from me.
In summary, the technology advance is important for us to analyze the feedback and response of the system for the DC motor in PID controller system. By using MATLAB Simulink, we are able to generate the data in order to analyze the stimulation and practical response of the control system. Here is the last part for our presentation, which is references. We got this from control tutorial for MATLAB and Simulink, and here is the link you can see. And we got from Hamoudi Safwan and Muhammad Raisha and Saleh Bashar with the title DC Motor Speed Control control using PID controller implemented by Simulink and Practical. And we also refer to the complete guide of DC Moto. There is no the and retrieve from link below. Okay, that's all from us. Thank you.
Thank you, everyone.
Thank you.